Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing about anything and everything which is related to construction and the quality control. Today also, I'm going to discuss about a very important topic or theory that every civil engineer or the site engineer must know. In the last videos, or we are discussing about how to calculate cement sand quantity in aggregate quantity in a concrete or in a brickwork or a plaster. And in this, whenever we are calculating dry volume to wet volume, there is a conversion factor. In concrete, we are making 54% more, and in the mortar, we are making 33% more. But why this 54% and why this 33%? Today, we will know what is the theory behind this, why the 54% to be increased in concrete and why 33% to be increased in the mortar. So stay tuned until the end to get the full information about why 1.54 and 1.33 in concrete and mortar conversion factor. And if you're new on my channel, can you subscribe my channel and hit the bell icon so that whenever I upload new video, you will get immediate notification. So without wasting a time, let's jump into the subject, that is what is 1.54 and what is 1.33 that we need to know. Now, what is concrete? First, we need to know. Concrete is a composite product made by coarse aggregate, fine aggregate, cement, and water. These are the main ingredients, but we are using GGBS, we are using the alcoform, or the microsilica, admixture, etc. But let's compare with the main ingredients like coarse aggregate, fine aggregate, cement, and water. And when you are adding water into this mix, they're making a homogeneous paste and the hardened paste that we call the concrete. Now, one thing we need to know, the main ingredient for the concrete that we already discussed. Now, what is happening? This ingredient, this coarse aggregate, they have the void in between two aggregates, and in the fine aggregate also there is a void in between two aggregates. And the cement, it's slightly less and it becomes very negligible or near to zero, and the water also same. But whenever we are taking coarse aggregate or fine aggregate in a dry condition, because in a wet condition we cannot pour or we cannot mix, so we need to wait in a dry condition. If you take the wet condition, that will happen, then the moisture will be more and the water cement ratio will be more, so we cannot wait in the wet condition. So we need to wait in the dry condition. In the dry condition, there is a void in coarse aggregate and the fine aggregate. So what will happen when we are adding water into the mix? They will start reacting with the cement and water, and they will fill the cement and will fill these voids. And whenever these voids will be filled, the ultimate product, there will be no void. But in the raw material, whenever we are waiting, we are taking the voids in consideration. So these voids we need to taking in the consideration whenever we are calculating the dry volume. That is why this dry volume is always increased, and this called as a void ratio. What is a void ratio? That is the deciding factor. What will be the wet volume calculation in or the dry volume calculation from the wet volume calculation. Now the theory is that the coarse aggregate, fine aggregate has the voids in between the two particles, and whenever we are making cement or the mortar or the concrete, these voids become zero, because the cement and sand or making this cement is making the void invisible. So what is happening? The coarse aggregate, there's a void. Whenever we are adding the fine aggregate, that void will be filled, and fine aggregate, there is a void. And when you are adding water into the cement, with the cement, that void also to be filled. So the final product will be no void or negligible, maybe 1% or 2%. But in the raw material, there's a void. What is the void ratio? It is different. See, cement is very negligible, it's zero. The coarse aggregate, it's coming into 30 to 32%, depending upon the quality of the aggregate or the source of the aggregate. So whenever we are getting the raw material, we need to find out what is the void ratio in order to get the right kind of quantities for the cement or the mortar. So but generally it is coming on 30 to 33%, and the fine aggregate, it becomes 20%. And also whenever we are calculating the dry volume, we need to consider the wastage, because whenever we are making or whenever placing, there is some percentage of wastage. So what is the percentage of wastage for the concrete? It's become 2 to 4%. So cement is 0% is void ratio, that coarse aggregate 30 to 32%, fine aggregate 20%, and wastage we need to consider, that is 2.24%. So total void, what will be the void? 30 plus 20 plus 4. Here it's coming. This is 30, 20, and 4%. So it's become 54%. But it varies from 52% to 57% as per the properties of raw material and wastage. So that is why you need to find out the what is the void ratio whenever we are getting the material. But in general, we are taking the 54% in consideration. This 30 to 32% void in coarse aggregate, 20% voids in fine aggregate, and waste is in 2 to 4%. In total, it's a 54%. So in the raw material or the ingredients, whenever it is separate from the concrete, it has the void of around 54%. So whenever we are making the concrete, the 54% will be added or will be refilled with the cement and the water, and it will make a composite or homogeneous material. So these 54% we need to calculate in a dry volume to get the 1 cubic meter of volume, because these voids will be filled whenever we are adding water or in the end product. That is why whenever we are converting from wet volume to dry volume, the 54% is coming. So these are the theory behind this 1.54, that is the void ratio or the void compressibility ratio, that we need to find out for the raw material, and according to that we need to calculate the co-multiplication factor or coefficient factor. It is varies from 1.52 to 1.56 depending upon the properties of the raw material, but in general we are taking 1.54 whenever we are converting from wet volume to dry volume the concrete. Now it's a more for the mortar. For mortar, what is happening? The main ingredient, we need to know what is the main ingredient here: sand, cement, and water. There is no coarse aggregate. So what will be the void ratio? Void ratio, we know cement is 0, sand is 20%, and wastage is calculating 5 to 13%. Why? Because it is assumed that whenever we are making a mortar, it is in the hand mix or the small mixture machine, and here the wastage is more in compared to concrete, because the concrete is whenever making it's all automated and well equipped, and so that the wastage is lost, but more so less. And but in the mortar, wastage is more because we are making the hand mix or the small mixing machine. That is why the wastage percentage is more. So total voids is got how much will be in the mortar? The 20% plus 30%, that is 33%. So the dry coefficient will be 1.33. So in the mortar, whenever we are transferring or from wet volume to dry volume, the coefficient factor will be 1.33 or the 33%. But again, it is varies from 1.27 to 2.35 depending upon the properties of the raw material and depending on the degree of quality control, so that the wastage will be less. So depending upon these, 1.27 to 1.35 is varies, and in general we are taking 33%. So whenever we are getting the mortar or the raw material, when you're preparing the mortar, find out the void ratio, and according to the void ratio you can change the percentage from 1.3 to 27 to 1.35 according to your raw material product. So these are the things behind the multiplication factor or the coefficient factor from wet volume to dry volume. I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comment, so that from your comments everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. Thank you once again for watching me.